Hi, this is Randall Schwartz, host of Floss Weekly. This week, Aaron Newcomb joins me. We're going to be talking about big data, really big data with Apache Cassandra. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Floss Weekly is provided by CacheFly at CACHEFLY.com.
This is Floss Weekly with Randall Schwartz and Aaron Newcomb, episode 392, recorded June 14th, 2016, Apache Cassandra. This episode of Floss Weekly is brought to you by Braintree. Mobile app development can be complex, but integrating your payments no longer has to be. With Braintree, your business can accept nearly every type of payment from any device with just one integration. Learn more at braintreepayments.com/floss. And by DigitalOcean, simple and fast cloud hosting built for developers. Deploy an SSD cloud server in 55 seconds. Try it today for free. Visit DigitalOcean.com, and once you sign up, be sure to enter the promo code FLOSS in the billing section to get your $10 credit. It's time for Floss Weekly, the show about free, libre, open source software. I am your host, Randall Schwartz, MerlinStones.com, bringing you each week the movers, the shakers, the big projects, little projects, projects you may be using every day, not aware of it, projects you may want to go download right after the show and check it out. I am currently speaking to you from the kitchen set, which is my apartment in Silicon Rainforest here. And hopefully the leaf blowers won't show up too quickly. Joining me today, as always, is a lovely and talented co-host. This week, no exception, Aaron Newcomb. Welcome back to the show.
Hey, thanks, Randall.
Okay, and where are you speaking to us from?
The usual place these days. I'm in my secret lair with lots of books and lots of kids' stuff all around. And if you could see my desk, you could also see all my projects and little boards and things that I'm testing out.
Nice.
So this is where I do a lot of my makering when I'm not down at the makerspace.
Cool. And I am running on about 2 hours less sleep than I want. So if I'm a little occasionally confused here, I think I'm going to assign it all to that. So this week, again, we have a wonderful show lined up. We have Patrick McFadin, who's going to be talking to us mostly about Apache Cassandra, but also a little bit about their company, DataStax. So we haven't had anything related to Cassandra on, but we've had a number of the NoSQL databases, of which Cassandra was one of the sort of original inspirations for. So what do you know about this?
I know a little bit. I mean, we do actually support Cassandra at where I work at NetApp. We support Cassandra and MongoDB, and I think there's a couple other ones as well. So it's a little different. I mean, we're used to supporting the big, Oracles and SQL servers and kind of those monolithic DBMS systems or relational databases. And so the support for NoSQL kind of changed things up on us a little bit. We had to think fast. So I do know a little bit about it. And so I'm excited to talk a little bit more about it today because it's certainly changed up the way that applications work from only using relational databases to now using NoSQL databases. It really changes things. It changes the whole paradigm a little bit. So I'm anxious to see what's going on with Cassandra for sure.
Yeah, and it seems like that's sort of the granddaddy of the projects as well. But let's back up a step, just for people who may not understand the difference between SQL databases, relational databases, and the notion of a document database, where everything is sort of arbitrary. Traditional SQL involves having tables that are essentially squares. We have columns, we have rows, and we do joins and relationships on them. Sometimes there's foreign keys so that we can make sure that if something is in a column, it's also like the primary key of some other table. But what's happened over the years is people have realized that not all data fits into that model very well. And in fact, we've gone through a lot of hoops to try to fit all that data into that sort of thing. And so along came this idea of a document database where you could build essentially, the easiest way to understand this is just, you have an arbitrary JSON expression, although they're not all using JSON, but they have an arbitrary JSON expression, can have arbitrarily nested arrays and dictionaries, hashes, all the way down. And so if you could just somehow put that into a database, and then run a query against that. Like you have many of these, and then you want to index them on a particular value that you think is going to be in most of the documents. And so it allowed for more flexibility. Another way to say this is schemaless, because you could, every document, although they typically aren't, every document could be a slightly different shape. So maybe only some of them have like a second phone number or a second address or whatever. Does that cover it pretty well?
Yeah, that's actually a really good explanation. I was just going to say, it's hard to wrap your brain around it at first. At least if you're someone like me who's come out of the more traditional realm, it's hard to wrap your head around. What do you mean there's not real structure, or there doesn't have to be a consistent structure? Because that's what we're used to. But it really does help with certain applications that want to do things in a different way and want to get outside the bounds that a relational database have, where you're really limited to rows, columns, everything's all in the same place all the time. So it really does, like I said, it changes the application paradigm quite a bit.
And it also, there are many challenges in doing this. Another thing that's also interesting to talk about and listen about is the whole idea of CAP, that there's consistency when we have this distributed as well. I'm sure we're going to get into all this with our guest, but we're going to bring him on in a second and actually hear it from the authority. But before we do that, I have an important message. This episode of Floss Weekly is brought to you by Braintree. By next year, maybe even next week, there could be a whole new way to pay. Maybe it'll be the next Bitcoin or the next Apple Pay, or maybe even both. Fortunately, Braintree's full-stack payment platform is easily adaptable to whatever the future holds. So you can adapt easily too. Accept everything from pounds to PayPal to that next big innovation from any device with just one integration. And when that new payment method comes out, all you'll have to do is update a few lines of code. No late nights, no complicated recoding, no stressing about staying ahead of the curve. Braintree Payments is here to help. There's simple and secure payments code you can integrate in quickly. The Braintree code supports Android, iOS, and JavaScript clients. SDKs in 7 languages: .NET, Node.js, Java, Perl, yay Perl, PHP, Python, and Ruby. Elegant code with clear documentation. So Braintree gives you an easy way to accept multiple payment types with one integration. Integrating it into your app is easy as inserting a few lines of code. Learn more at braintreepayments.com/floss. And we thank Braintree for their support of Floss Weekly. So let's go ahead and bring on our guest. Patrick, welcome to the show.
Well, thank you very much. I'm in your, soon to be not studio, if you can see behind me. If you're on the video, you can see behind me, you'll see some movers moving right now.
Some movers and shakers, probably some shakers. All right,
yes. Randall.
And I was going to say, where are you speaking to us from? But you're in the studio.
I'm in the studio and you're not here. I looked around.
I know. I've only been there maybe a few times, and unfortunately not recently. And now it's going to be gone. It's going to be off.
Yeah, no, I feel like I made a good move coming here because this is the last time I'll ever be here.
Yeah, indeed. So I described what I thought document databases were about, and maybe Cassandra in particular. Can you give us sort of the 30,000 foot view? What's Cassandra about? How did it get started?
Yeah, so all right, I was listening to that. So first of all, Cassandra is not a document database, and that's first clear distinction.
Okay.
Document databases are a definite class of database, or NoSQL database, and that's where you see like Mongo and Couchbase. Those are different. Those are document databases. Cassandra is not. And I also heard Aaron say something about schemaless. Cassandra is a schema database. However, it's a very flexible schema. So Cassandra is really a different type of database in this realm. So it's known as a column family database or a column-oriented database. It's not a columnar database. I mean, you can get in the weeds really quick on definitions. I'll give you probably the easiest way to describe it is that it's a distributed hash tree. Just that simple. We've created a great query syntax on top of it called CQL, Cassandra Query Language, that gives it an SQL-looking feel. So it has a create table, you do selects, you do inserts, updates. So from a data model's perspective, it looks very similar to what relational databases are, but under the covers, it's completely different. And the biggest difference, of course, is the way that it scales and the fact that Cassandra is a distributed database at its heart. It's not something that's tacked on later. If you look at the roots of where Cassandra came from, it was originally based on the Dynamo paper from Amazon, which is, if you're a computer science distributed nerd like me, that was kind of like the seminal text, that was the Magna Carta of distributed databases. Even though Amazon never really built it, they published a paper about it, and it was wonderful because it described a lot of hard problems in distributed databases, like how do you distribute your data in a consistent way? How do you manage all the different failure modes? How do you do things across a WAN link? It covered so many bases that there were databases, and this is around the 2007 timeframe, 2006. There was a lot of databases that sprung up around the Dynamo paper, but only a few really stuck. And Cassandra is one that has stood the test of time, more or less.
So I was completely wrong at the beginning of the show about what this was all about. I think I got confused by the fact that it's a distributed database. So how is it different from those document stores?
So I'm actually glad you did that, because that is probably what I deal with the most, is the confusion. There's a little bit of overwhelm with engineers. I mean, let's face it, there's a ton of choices, right? Up to maybe 10 years ago, there was really only a couple of choices for databases, and that made it easy for engineers. Now there's just this massive plethora of choices. And so that's why I'm glad you said that. So what is different about that, and what is the difference between a document database and Cassandra? Document databases, like you said earlier, are based on this schema that's basically a JSON document. You throw some JSON at the database, and it says, I'll figure it out for you. So there's not really a schema. If you throw some JSON at it, you can query it, you can index it, but at its core, it's really not around a schema. And the way that you distribute that data is a bit different as well. Some of these are based on master, like the master follower, leader follower type architectures, where you have this one particular server that controls all the rest, and the rest follow. So that's similar to like a replication in something like MySQL. So the failure modes are a little different. So if, for instance, if the leader node was to die, which happens all the time, then you get into this, okay, now we have to deal with the failover. Cassandra is a different type of database based on partitioning, and so the partitioning allows you to create these ranges of data that belong on different nodes but are replicated in asynchronous real-time mode across multiple nodes. So it's a shared nothing architecture. So there is no leader election. There is nothing that's just sitting there and saying, I'm the leader of this cluster. Every node is equal. But the data structure underneath is typed, and it has real structure, it has real schema. So way from the surface, way cleaner and closer to what you'd expect in a relational database.
Okay, I think I'm getting a bit more of it then. So this is distributed in the sense that I'd run this on multiple machines.
Right.
But do I have to define the partitioning, or does that all happen transparently?
You could do it either way. Of course, I think one of the downsides of Cassandra is it's highly configurable, and one of the upsides is it's highly configurable, just like
Nice.
SendMail.
Yes.
You can manually choose the partition ranges, which it's much more an advanced topic, but there. And then there's another way to do it using virtual nodes, which is where it picks the ranges of those token ranges automatically. And so that's really kind of one of the cool features about Cassandra. So when you have a node count of say 4 in a cluster, which is about the minimum, I would say, and that's kind of also an interesting thing. No one runs just one node of Cassandra. You always want to run in a cluster. And when you run in a cluster configuration, we're expecting that you'll probably want to expand that cluster. You'll want to build it out. And so that's a bootstrap operation, and that's runtime, that's online. And you'll see lots of demonstrations if you Google that. You'll see people doing that all the time. It's almost like a little stupid trick you can do with Cassandra anytime to wow your friends and impress your enemies. But adding nodes in real time means that whenever it inserts itself into the node or into the cluster, that node announces itself, and then the nodes around it rearrange their token ranges in real time, stream that data into the new node, and then that node becomes online. Think about that in a real-time situation where I need capacity now. My background is I was an Oracle DBA. If I need capacity now, that meant I had to call somebody like HP or Dell and order a server and wait for it to get delivered.
So how does this all fit into big data then too? Maybe we should just cover all the high level topics for people that are catching up here. So you explained a little bit of the difference between NoSQL databases. Now say, how does that fit into big data? How is it used when you're mining data for big companies looking for little bits of data that can help them sell more stuff?
Yeah, so big data was a catch-all phrase for a long time. If you think about what maybe started that, it was Hadoop, right? Hadoop was the another thing that sprang forth from another large entity, Google, MapReduce, and making this massive amount available. This massive amount of data available for analysis. So Cassandra fits in a different part of that. If you're looking at large-scale data, Cassandra is faster in transactional workloads. I like to tell people Cassandra is closer to your users. It's running applications. Mobile applications, for instance, are a great use case for Cassandra. So you're putting it right on the edge, where something like Hadoop or Spark sits a little farther back from your user, and that's a huge analytic workload. Now, DataStax, we've built this system around Cassandra that also uses Spark, and that's something we can use to analyze data that's sitting in Cassandra. So big picture, you have this high transactional data, things like events that are happening, mobile applications are constantly spewing data, and so all that's really high-speed transactional data. But then on the back end, you can use something like Spark. We'll use Spark to analyze that data, roll it up, and enrich it. So now we're getting into some combinations that are important.
Yeah, so is that maybe explain that a little bit more? I'm just making correlations in my head here to what I'm used to, which is more the Oracle world, Oracle database and relational database world. So is it more similar to say Cassandra is more like an OLTP type of database workload, whereas maybe some other NoSQL database engines are more like a data warehouse?
Exactly, that's exactly it. Cassandra is an OLTP database. You see the typical workloads that are replaced by Cassandra, it's Oracle. And right there on your website, on your mobile app, it's very close to the user, like I said. So, and that's where Oracle has traditionally been, or MySQL, or Postgres. So replacing those workloads is really critical because those databases are hard to scale. Now, I know that they can be scaled, but what happens when look at what we've created for ourselves here. I've worked in the web performance industry for a long, long time, and we just couldn't do any more. We started doing stupid things like sharding databases. And that's how we got scale out of those databases. It was getting into a square peg, round hole problem. So if you think about that problem just being solved, that's great, but you nailed it. That's not the big picture, that's not the entire picture. You do need to analyze data because that data, it's great when it's transactional, but you really need some insight in that as well.
Right, absolutely. And another question I had was, again, just trying to keep this at a higher level. So I'm assuming that you need, you mentioned, you can roll things out quickly and just use commodity stuff, I think, but don't you need like really super fast servers and super fast storage? I mean, how do you actually get the performance off of a commodity server with commodity disk?
Well, commodity, some value of commodity, right?
Yeah.
What is commodity? Most times now that means some cloud instance somewhere, Amazon, Google, Azure. Those are turning into the commodity server. Now, traditional data center type servers, if you look at what you buy now, what you can buy now, they're ridiculously powerful. We're beating Moore's law to death. And what it's coming down to is memory and storage. Memory is the cheapest thing you're putting in your computers now. Storage is changing so rapidly. Not 5 years ago, SSDs were so exotic, no one was using them. Now they're almost the standard. And that kind of storage is what we really hope that you'll be using, because Cassandra is a persistent database. It has to read and write data to a disk. And if you're running on a 7,200 RPM SATA disk, you're going to get just that. You're going to get that kind of 20 millisecond read time because the disk is that slow. So do you need to be on exotic hardware? Not exotic. It doesn't have to be anything really crazy. But your mileage may vary, and it supports everything from the lower tier to the higher tier.
Okay, great. So if I want to, it really depends on my performance needs. I could probably set something up myself, but I may get some advantages to going with a vendor, like somebody like I work for, who might be able to provide that really fast back-end storage. And you're going to want to probably load it up with memory as well so that you can get the fastest response time possible.
Right.
I also was kind of wondering, as we were talking about transaction-based systems as this is, I mean, how would you even stack it up or compare it with something like an Oracle database? I mean, can you just compare the number of transactions, how fast transactions can get in and out of the system to give someone, if I was like, if I was a DBA and I was used to Oracle or DB2 or SQL Server, and I was looking to go faster and lighter, what kind of metrics would you use to be able to tell that story?
Yeah, that's a great question, because I was actually involved in a NoSQL consortium that, surprisingly enough, Oracle had put together. And the idea, and it was a bunch of us that were a little more academically inclined, that were trying to be, very neutral and figure out a common pattern that we could work around. And it was think of all the NoSQL databases and then Oracle and others, but how do you define the difference? And I think what we came to a conclusion was it's so workload dependent, and these databases are becoming more workload specific, that it was almost impossible. So I think really what you need to rewind to is the use case. So what you should typically expect in Cassandra is, several tens of thousands of writes per second and reads per second per node, which is significantly higher than what you can get off of Oracle or any other database, really. But if that's not really your problem, then, and that's where this is kind of the big difference, is sometimes how many writes per second is not my problem. My problem is I want to get as close to 100% uptime as possible, and I need to be across multiple data centers. Now you're just eliminating databases based on what they can do, not how fast they can do it. And I see that as a much more compelling reason to use something like Apache Cassandra. And I'm not alone. I mean, of course, I'm going to say that, but I think the numbers speak for themselves. On DB Engines, we're now the #7 database. I mean, that's pretty incredible considering this is an open source database.
Yeah, so when you say #7, I mean, where are you in terms of who would be above you and who would be below you? I'm just curious.
Well, all right, so this is there's a fun fact. We just passed up Microsoft Access, which is a sad thing, really. But I think that was great because, I mean, you think about Microsoft Access, the most ubiquitous database on the planet. It's just everywhere because we wrote a lot of VB6 apps to support it. That is, we just passed that one, but the ones above it, you're looking at the top one, of course, is Oracle, MySQL, Postgres, Mongo's up there, I think DB2. I mean, this is a pretty good crowd to work with, right? If you think about the traditional large databases, they're all there, and they're just right above where we are.
Yeah. And one other thing I wanted to just clarify before we get maybe a little bit more into the weeds here is, when you talk about NoSQL, I mean, the whole reason it's called NoSQL is because traditionally you don't use SQL statements, right, to access data like you do in relational databases. And I know we had ToroDB on the show not too long ago. I think it's called ToroDB, and they're writing some sort of I'm trying to remember. Go watch the show if you haven't seen it. Some sort of a wrapper around. So you can do SQL type queries to NoSQL type databases. Do you guys support that? Is there a need for that, or is that? I mean, it seemed pretty cool when we were talking to them. I think they're working mostly with MongoDB and Postgres, but.
Well, yeah, and so SQL generally, there's two camps there. There's the query language itself, so you can get a nice expressive query language. I love SQL. SQL is great. But I think it also comes with the baggage of ACID compliance, which is just kind of built in. That's what it does, right? And so relational databases, not only do they have SQL, but they also have the ACID compliance, which means that you get some transaction guarantees. You can do a commit and a rollback. That's really comfortable for relational developers. It's, you get it no matter what. It feels good. I could do a rollback, right? That's like a Control-Z or a Command-Z. I can just go back, right? When you don't have that, then you get a little nervous. But what comes with the ACID compliance is a ton of baggage. It makes it a lot slower because you're having to lock things. You're having to be exclusive. And concurrency is hard. It's really hard. And if you don't have a need for it, I think that's where those databases that are pushing really hard that say, hey, use SQL, they're really saying use ACID compliance. But here's a really big deal, is that almost every bank uses Cassandra. Banks are not ACID compliant. Sorry. They're eventually consistent.
I want to talk more about the difference between ACID and CAP in just a second, but I have some business to conduct first, because whether you're developing an app, a website, or working on a server-based project, you need flexible, reliable, and affordable hosting. DigitalOcean offers Droplets, which are virtual private servers that can be customized and deployed easily to host websites, web apps, production applications, personal projects, virtual desktops, and almost anything else you can think of with full root access. This helps you get your project off the ground quickly and makes it easy to scale when you find success. DigitalOcean is used by over 600,000 developers, including me. I found out about them at scale last year, and I've had a box running ever since. Deploy and configure your Droplets via streamlined control panel or simple API. You can choose your OS: Ubuntu, CentOS, Debian, Fedora, CoreOS, and FreeBSD. That's mine. I prefer FreeBSD. Select one of the many pre-configured one-clicks like Drupal, Docker, or Node.js to get up and running quickly, or build the exact infrastructure you need with root access to servers running 100% SSDs. There you go, 100% SSDs. In the state-of-the-art data centers around the world. Highly scalable to meet the demands of rapidly growing application or business. You can also use advanced features like floating IPs for high availability, private networking, and automated deployments via an API. An extremely active community with a large and detailed set of tutorials and all the ways you can use your Droplet. Want to configure a LAMP server? Set up a virtual desktop or VPN? They've got you covered. And it's so easy to get started. You can deploy an SSD cloud server in as little as 55 seconds. DigitalOcean has had incredibly affordable and straightforward pricing. Servers start at only $5 per month. There's also hourly pricing available starting at less than a penny per hour. But we're going to make it so you can get started today and deploy an SSD cloud server for free. Visit DigitalOcean.com and create an account. Once you confirm your email and account information, go to the billing section and enter the promo code FLOSS for a free $10 credit. That's plenty to get started and explore what DigitalOcean can do. That's DigitalOcean.com, and once you sign up, enter the code FLOSS in the billing section to get your $10 credit for free. We thank DigitalOcean for their support of Floss Weekly. Now let's get back to that for a second. So what's the difference between ACID and CAP, and why is it important?
ACID has been around forever as a concept for relational databases because it managed that transactional guarantee, and that was part of the original relational database design. CAP came along later when it was actually is much more of an academic problem. Is how do you solve this problem of databases that are not connected with each other? So my academic background is in distributed computing, and there's lots of math and proofs around the fact that you have computers that can't see each other all the time. And that's the biggest problem to solve in distributed computing, is these so-called split brain problems. And so CAP gives you some of that iron triangle of trade-offs. You have the consistency, availability, and partition tolerance. Partition tolerance meaning computers that can't see each other. And that gives you some guidelines to work with. So, it's like cost, schedule, quality, pick two. This is CAP, pick two. And so databases that are consistent and partition tolerant, those are very difficult and almost impossible. And so you really have to think about things like availability and partition tolerance, where that's where Cassandra is. It's built around high availability and partition tolerance, which means that there is a whole lot of things that it has to be able to do to make that work. ACID compliance at that point is not one of them. ACID means that whenever you set data into the database, that there's all these guarantees, and that when you go to read that same data out, you will exactly get what was written in. And that is really kind of the tenet here, that strong consistency, and that's what makes people nervous. But the other term you hear a lot with CAP or AP databases is eventual consistency, and that can bring a lot of fear in the hearts of a developer or a DBA. It's like, wait a minute, eventual consistency is like what? That's like Amazon, the slow purchase where I get it like in 5 days? No. This is, we're talking milliseconds. But what that says is that there's not an absolute guarantee that if I write the data, as soon as I do a read, it will be on every single replica. And if you think about a distributed database, what if one of those replicas is offline? The database should keep going. And that happens all the time. I think if you remember back a couple years ago, or a year and a half ago, Amazon decided to reboot all of our instances for us, the great Amazon reboot. The only people who were not nervous and flipping out were people using Cassandra, and like Netflix. And they tweeted out, we lost 300 Cassandra servers, 0 seconds of downtime. So that's AP in action right there. Now with an ACID compliant database, that you're going to have some downtime. You're just going to have to deal with that, or deal with the failover, which is going to be seconds or minutes.
So the idea is that we have multiple partitions that are all eventually going to get the same answer, but we might for a few milliseconds have it where we've written 5 one place and the old answer 4 might be retrieved if we ask one of the other partitions.
And so, yeah, and that's exactly it. But we give, the Apache Cassandra project has always been about choices for developers. And by default, you can have some good guarantees, but see, that's where we talk about with our replicas. So you have, say, 3 replicas. You also have this notion of consistency level. And consistency level is something the programmer, every write and every read, you can set a consistency level. And the consistency level could be anything from very loose consistency, where I want one replica to acknowledge the write or the read, all the way up to the ultimate strong consistency, which actually uses Paxos to do a lock. So there is a locking mechanism built into Cassandra as well. We call it lightweight transactions, lightweight because it's not a full commit rollback, but it gives that end user, the programmer, the ability to dial it up. Now with something like that, you will start losing your availability and partition tolerance with that. You're going to strongly consistent. So, but that's a choice. You know, given the choice, which way do you want to do it, and how's that going to work for your application?
Now, what kind of mechanisms does Cassandra have for doing something like read, modify, write? Like if I'm doing, say, back in the classic day, doing like web page hit counting. Is there a way to do that with something like this?
Well, so yeah, there are counter types in the database, and so counter types are just increment, decrement. Of course, they're not idempotent. So if you say count twice, you get 2, and that's one way of doing it. There is a compare and set method. That's the lightweight transactions that I mentioned. That there's edge cases around, like say if you're creating a new user and you have a potential collision, you know, we have 2 McFadins that are going to try to collide with each other. That's a situation where I want exclusivity, and so that's where you dial up that to a lightweight transaction.
Okay, and so we should let you talk about your company a little bit here as well, since you're taking your time to come out here. So what's the relationship between DataStax and the Cassandra community? Okay,
well, so my favorite thing to say is DataStax is a company that loves Apache Cassandra. That's what we do. We don't own it, of course. It's an Apache project, and I think what is a more modern notion is that we are a commercial company that has sprung up around an Apache project. And we do a lot of work with Apache Cassandra, but that's not the only Apache project we work with. We work a lot with Apache Spark and Apache Solr as well. And now Kafka as well. I do a lot of work with Apache Kafka. So we don't support all of those directly, but we build a final product called DataStax Enterprise that we ship, and that's a proprietary software. It's an integration of those things, and we put tools on top of it. Really, we're trying to make it easier for developers to work with complex technologies that sometimes are hard to blend, make work together. And if you have kids, you know, getting them to get along in a car is hard. Try to get all these technologies to work together sometimes can be hard. So that's what we're trying to accomplish.
And those are just buzzwords for me. Can you describe it slightly, a little bit about what those are?
Yeah, all these Apache versions. There's Apache this, Apache that. I could have said Apache want and Apache want.
And I wouldn't have known that you weren't making it up. Yes.
So, all right. So Apache Cassandra, of course, is a relational or non-relational database. So non-relational. So that's your transactional layer. That's what really our core is. And so if you think of Aaron mentioned before his Skype blew up, that we have this need for analytics in the world of data, and that's where Apache Spark is there. Apache Spark is an amazing framework for doing massive parallel analytics, and it comes with a lot of great stuff like Spark SQL, which I love because now I can go back and use my SQL skills again, do joins and things like that. But that's more of an analytics workload, so it's not real time. Near real time for some things. And then Apache Solr, of course, is the nice wrapper on top of Lucene, and it does things like indexing data sets. And so the way we've integrated it is that as data is ingested into Apache Cassandra and in the Cassandra table, we have a way that automatically indexes the data using Solr and will present it as a Solr. You can query it via Solr. So it does more of a textual search. You know, if you have a document, something like that, finding the word Floss Weekly in it or something. See, I give you a little pitch there.
Hey,
But
thanks.
it's different types of things you need to do with data, and each one of those does that.
And so your company supports that. It provides
Right.
commercial consulting services and 24/7 call handling, things like that.
Right, and so that's pretty critical. Not only do we wrap it together and sell that as a package, but we support it, and which is, I think, critical for any of these open source projects to have. If you look at, there are companies that support open source projects. They're so critical to these open source projects, like Confluent does Apache Kafka. They're really critical for that, and Cloudera Hortonworks, they do Hadoop. We do those technologies, but enterprises, like if you're working at, say, a bank and you need a guarantee that if something goes bad, you have someone to call, but you know that it's certified at a certain level, that's what gives that legitimacy to an open source project, and doesn't seem so much like, if you're a very conservative IT person, you don't feel like you're really going off the deep end, you really actually have some help here. So that's what we provide.
And do the people that work for DataStax primarily work on Cassandra then?
We have a lot of people that work on Cassandra. We have a lot of people that that work on integrations with Spark, and as well as Solar. I think our primary focus is on Cassandra, of course. We just had we were part of a committer conference last week with Cassandra, but the Apache Cassandra committer base is really, it's not just DataStax. We have committers from lots of different places, Wikipedia, Apple, Yahoo, Japan, I think, is another one that's coming along. So it is great, because if you look at those names, those are all names that are having scale problems. And that's the beauty of being an Apache project, is that you get this diversity, but some smart people. I mean, I'm humbled when I'm in a room with these committers that they'll even let me in the door, because they're just such smart people from all these companies.
And who decides the roadmap then for Cassandra?
There is a PMC, there's a project management committee, and that's a part of the Apache project. And a lot of it really happens in JIRAs. There's no roadmap meeting, really. It's just as features are introduced into JIRAs, in the Apache open source JIRA, it turns in, some of them are more entertaining than others. You get into some really interesting discussions, but that's really the community base. It happens all in the open, and I think that's one of the beautiful things. And it's really hard to explain to someone who's never been involved in an open source project. They're like, well, where's the secret roadmap? No, it's on issues.apache.org, and that's where it all is.
Awesome. So that really sort of helps then to have this all really be out in public and to really decide things. Because I ask this question probably of almost every project that we bring on. It's like, well, who decides? And especially, and this is more of concern for projects that are sort of only open source, maybe in name, in that,
Right.
We give you the source code, but really what our customers need is what comes first. And I'm glad to see it. Sounds like it's almost the opposite.
I'll give you a great example. This just happened. There's different types of ways to compact data, and it's a background process. There was an original plan that was brought forth by Spotify because they were trying to solve a problem, and then another company, they started working on a different plan because it was solving their problem. And that all happened in the issue tracker inside the JIRAs, and lots of discussions were happening around that. Not once did I say, and DataStax told them this is the way it's going to go. And I think that's really critical.
So I know there's a lot of other players here in this space, and we've gone over some of the differences. But there's even within Apache, isn't there a Apache Cumulus or a Cumulo or something like that? Like, aren't there even other Apache projects that cover this type of transactional system?
Cumulo is, I think, roughly based on Dynamo as well, and that's actually something that's a very interesting feature of Apache is they have tons of competing projects. If you look at Spark and the Hadoop project, they go at odds quite a bit, even though Spark does integrate partly with Hadoop. So there's no competition scope inside Apache. It's more of a survival of the fittest. So. The incubation process is pretty clear, and we already have one of those, so we're not going to do that anymore. I think they have like 3 web servers. So The Apache Software Foundation is really only interested in making sure that they cultivate a nice, flourishing open source environment and not, oh, the source of truth for the right way to do things.
Yeah, I think there's another one, HBase or something.
HBase is a part of the Hadoop project, right?
Yeah. So
yeah,
I mean, it just gets it's so complicated. Like, you know, when I was doing this, when I was a storage admin supporting database workloads, you know, it was like, okay, is this the Oracle database or is this the DB2 database?
Yeah,
That was it. You know, that was it. There was nothing else. And now it's just like all these things you got to keep track of, and what does what. I mean, it's got to be hard to keep track of for people that are trying to figure all this stuff out. I want to say we're in the golden age of databases, but I also, you know, along with that comes like, you know, just explosion of all these different things you need to know about. You mentioned earlier Netflix uses this. Is there any other names you could drop in terms of who's using it and what they're doing with it?
Name dropping, huh? You know, the easiest thing for me to say is just look at our Cassandra Summit. We have a Cassandra Summit happening in September. We had it last September. Just look at the list of names that are presenting there. You know, Sony PlayStation, for instance, is running on Cassandra. So, you know, when you want to kill your buddies online, there's a great to have uptime, right? Demonware, Call of Duty, you know, that uses Cassandra. Walmart, these are the list of names. Target, Best Buy, it just any big name you want to think of that's doing anything at scale. Probably my favorite thing I heard from a user was, you can assume anyone doing anything at scale on the internet is probably using Cassandra.
Yeah, I'm looking at a list of, and I don't know if this is up to date. I think this is this is a Wikipedia page, so who knows, right? Take it for what it's worth, but I see Apple.
Wikipedia uses Cassandra. There you go.
Wikipedia.
Nice.
Let's see. Dig, of course, I think was a famous one back in the day.
Right.
There was a couple other big ones in here. Oh, Reddit, of course, right?
Reddit, sure.
Yeah,
ING
Twitter.
Bank, ING Bank in Netherlands, huge supporter of Apache Cassandra. You know, if you're looking for banks that are doing this kind of stuff.
And banks are always great to have, but they're really, you know, they don't usually like to talk about what they're doing. So it's hard to get them to go on record saying they use anything.
They're such good community members because they know that and they're kind of bucking the trend. And I think they're doing that for a reason. And this is probably my final point on that, is that this is a different, you nailed it. This is a golden age. And I think there's companies that are realizing that, and to be relevant, you have to participate in open source projects as well. Yeah,
that's the silver lining in the golden age.
Yeah, absolutely.
I'm sure there's something about bronze we could fit in there too, but it really, you're really right. I mean, that you do have to know about this kind of stuff, and so there's a need for companies to go out and support this stuff, and there always has been. That's just the way it works. It's one of the ways we can keep these open source projects going. Actually, is to have companies that are willing to go out and build a business around them to keep them going. One other question I had was, you mentioned, or Randall mentioned, I guess, you know, how the roadmap is developed and who controls that and the governance and all that. But what actually is on the roadmap? What's coming up? What can we look forward to seeing in future releases?
Oh, madness and craziness. Well, we're doing we're on the 3.x branch right now, and the changes that are happening there are so amazing. We just introduced a new indexing scheme, which is gaining traction. If you think about it from a data model standpoint, the more flexibility there is great. There are some enhancements that are coming to the storage engine. The big one that I think is really important is managing really large servers. If you look at what we're deploying now, you can't find a one-core server anymore. That doesn't exist. And pretty rapidly, we're going to see 128-core machines. 2 terabytes of memory is now a thing. You know, you can buy that on Amazon. So being able to deal with that much hardware is a different problem in server design. And we have a whole thing happening now in the Apache Cassandra project called Thread Per Core, which is if you're familiar with NUMA, those concepts of being able to manage that much resource efficiently, and it will massively increase the performance of Apache Cassandra just based on that. That's one of the things I'm really excited about.
All right. Hey, a breeze started coming through the house here, so I'm like, I had to get my coat real quick.
Sorry, I could have kept
it's
talking.
like, yeah, you could have kept talking. Actually, it was just fine. But I'm back again. We're almost out of time, so I want to start wrapping up here. Is there anything we haven't talked about yet that you'd like to make sure our audience is aware of?
Let's see. Well, if you want to see more of me and probably wearing this exact shirt, you can go to academy.datastacks.com to learn more, to get certified at using Apache Cassandra, be a part of the great world of Cassandra developers. Again, this is a great career skill. I mean, look at the number 7 database. You probably want to know this now. And also we have our Cassandra Summit coming up in September, which is a great gathering of community. And every year, it's like the Burning Man of NoSQL databases. It's so much fun, although we haven't burnt anything yet. I did blow something up last summit, so maybe we'll do it again this year.
That would be cool. And you said certified. What's the certifications around this?
Yeah, so we recognize, I mean, like any technology, there is a need for certification in the industry just so that you can show your credentials. So we have a certification process for developer, for admin, and architect. And it will hopefully lead to getting people gainfully employed, if not at least qualified in a way that we can say, yes, this is a person who knows what they're doing in this technology. Because as you mentioned, it's kind of a wild west as how many different technologies, but this is emerging as one of the top ones. And to give people, the people who are trying to do this as a living, some sort of certification is only going to make their lives better in the long run. Plus, we know that they're getting a good quality education about how it works, and so we don't have to pull them out of the fire if they go off the rails.
We resist certification in the Perl community. We do that by basically saying that Larry Wall says there won't be any blessing of any certification anywhere, so that's nice. Because what does it mean? It means you sat in a class somewhere for a while and you answered some questions correctly.
Do you want me to argue on this? I will.
It's my show. I can do what I want.
Yeah, you can. Yeah, but I'm going to argue with you. You know that, right? Maybe over drinks sometime. That'll be great.
Maybe. I'm looking forward to that. Final 2 questions. What's your favorite scripting language?
Oh, yeah. If I didn't say Perl, it would be bad, huh? Well, I can't say Perl.
You say whatever you want. Say what you want.
I love Python. Is that still considered a scripting language?
Yes, it is.
Sure, of course. Yeah, it's great.
Okay, and favorite text editor?
I'm using Atom a lot right now.
Ooh, Atom, that's a good one. Yeah, so we're hoping to get them on the show at some point because it's a really new,
it's a lot
interesting
of fun. So, it's new and shiny, right?
Indeed. Okay. Well, it's been a pleasure having you on, and I'm glad we could finally get a chance to talk. And well, hopefully this will wake up more people about using Cassandra and maybe even using your company services.
Great. Thanks for having me on.
Awesome. That was Patrick McFadin talking to us in the studio. Actually, in the studio, if you're watching the video, all sorts of stuff going on behind his back. So we'll talk about him behind his back now. Aaron, what do you think?
Oh, this is great. I mean, this is right up my alley. So I love talking about this kind of stuff, especially when it's transactional things, because that impacts the bottom line for a lot of people's businesses. How fast you can get that response time out to the end user is usually the critical factor. People talk about the importance of big data and the importance of data and analytics, and it's true, it's important. But at the end of the day, even if you know everything about the customer and you can't get that transaction through the system and back in time for that customer not to go to somebody else's app or to go to somebody else's store or whatever it is, they lost the business. So this is really cool. I know I learned a lot about Cassandra in particular. So now I'm kind of excited to go back and see in my company what we're doing to support it and what kind of story we're telling. So I'll be talking a lot more about it, I think, at least internally in the office in the weeks and months to come.
Cool. And I learned that I was completely confused about what Cassandra was. But that's okay. So much for my 1 hour of research I do before every show. I apparently did not discover everything I wanted about that. Anyway, but that's enough said. Okay, so before I freeze to death here because the breeze keeps coming through, we got Biturgia coming up next week. That's software development analytics, so you can see the progress and rapidness with which you are doing your rapid development. We have Lisk after that, which is a JavaScript-based blockchain sidechain apps in the cloud. That sounds pretty interesting. Aurelia, which is a JavaScript reactive framework and being done by people who used to be on the Angular project, but decided that they didn't like the direction the project was going, so they'd start their own. Koha ILS, which is a library information system. LucidWorks, which is all about searching your data, getting answers for things, probably similar to Solar and other projects like that. Karina, which is easy to use, instant-on native container environment from Rackspace. We have someone from talking about the open source projects at Capital One. We also have Cluster HQ projects. And we just added to the schedule Linux Presentation Day, which, as I understand, is a sort of European-wide single day where everybody starts talking about Linux for a change, which is kind of fun. So those are all on the schedule right now. Most of those, in fact, came from OSCON, where I was just at. Talking to various projects there. If you want to find out who else is coming up on the short list, we have the big spreadsheet at twit.tv/floss. That's the homepage for the show. And right there, if you don't see the project you want on that list, you can please email the community leader or the head honcho, wherever, and tell them to email me, merlin@stonehenge.com. My address is on that spreadsheet. You can hear the shaking in my voice because it is cold in here. It's like, I'm freezing. Okay, we have a live stream. A couple questions submitted today. That's at 9:30 a.m. Pacific time on Tuesdays at live.twit.tv. You can go there and ask questions of us. You can follow us on Floss Weekly and Google+, and also at Floss Weekly on Twitter. You can follow me at Merlin on Twitter, MERLYN. And also Randall L. Schwartz on Google+. That's where I primarily source my material. I'm going to be, is it next week? 2 weeks from now. 2 weeks from now at YAPC North America. No, actually, it's next week. And then the Red Hat Summit in San Francisco, talking to people there about more things to talk about on the show. Texas Linux Fest, I'll be right back in Austin, which will be fun, except I hear it's going to be a lot warmer because it'll be definitely in the middle of summer now. I'm not going to be at FISLA in Porto Alegre, Brazil, because I'm a little concerned about being a vector for Zika, so I'm not going to go there and be that guy. But in September in Hotlanta, I'll be at DragonCon on the EFF track and hopefully on the podcasting track. They have not gotten back to me yet, so I have no idea if I'm on the podcasting track or not. That's all I have to plug right now. How about you, Aaron?
Yeah, you can follow me on Google Plus or Facebook or Twitter, whatever you want. Doesn't matter. I'm there. I post occasionally. And you can also, if you're in the Bay Area here, San Francisco Bay Area, and you want to come up to a great makerspace, you can come up to Benicia Makerspace, which is the makerspace I run, where we just got done. We went over to the high school and built our laser maze, this huge thing you crawl through with lasers and sounds and all kinds of stuff. It was really fun. We did that for graduation for the high schoolers, and they had a great time with that. And also, if you're a Linux user, you might be good for this, Randall, because I know you're not always using Linux. So I'm kind of curious to know why either you don't run Linux, or troubles that you had as you were getting started, getting used to Linux. Like, what were the things that bothered you most, or if you had a hard time with a certain concept or figuring something out? I'd love to know what that was, because I'm working on a new book around Linux and makers that use Linux. So I'd love to be able to put some of that stuff in the book. So reach out on Google Plus or Twitter or something and let me know and what your thoughts are on that. I'd really appreciate it.
Yeah, what's an RPM? No, just kidding.
No, hey, that's in the book. That's in the book.
I can hear hundreds of people reach out to their keyboards right now. Randall, of course you know what that is, right? Right? Yes, I joke that often that I don't run Linux anywhere that is useful to me. So, but all my clients use Linux, so I of course have to know enough about it for that.
Right.
Yeah, so I'm kind of your target audience, but not you really.
Kind of are. I mean, you know enough about it though that you probably know all that stuff. But it would be great to get some, this was really hard, I couldn't figure out. Package management systems. That's a great example of something that's hard for people. What do you mean? There's no Windows updater? Like, how do I update my packages? So that's already in the book. But yeah, those kinds of things would be great to know from people. What did you have a hard time with when you first started using Linux, or why don't you use Linux? What don't you understand? I want to know.
And why does LS have so many switches?
Why does any program in Linux have so many switches?
Because it's GNU.
It seems like they all do.
They throw lots of things on things in GNU. It's a little crazy. That's why I like BSD better. Anyway, all right. Hey, before I freeze to death, I better wrap up the show. We'll see you all again next week on Floss Weekly.